approaches infinity, the limit is x approaches negative infinity, and we need to find when the denominator equals 0 with the numerator does, right? That's our vertical and horizontal asymptotes. A problem like this shows up on the AP exam quite often. It's not even calculus, it's pre-calc, but it shows up. So the limit as x approaches positive infinity. Limit as x approaches negative infinity. -2. And so immediately I know the answer is E. I don't even have to find the vertical asymptotes, but I will. How do I know the answer is E? It's only one that took into account both horizontal asymptotes. So if you think about what this question is really testing, this question is really testing, can you find both horizontal asymptotes? So for the again. And then I think it's the only one with the correct vertical asymptotes as well. Because what are the vertical asymptotes? When does the denominator equal 0? Negative and positive 2 because that denominator factors. So I think that's the only correct vertical asymptote as well. What is the domain of f of x? Occasionally questions like that will come up as well, or at least ones where you have to know that. And this is a tough question. What should you be thinking for domain? Okay, what can x be? And you might have learned in pre-cal or algebra 2, you might ask yourself, what can x not be? What can x not be? What would be the problem in this function? What would create problems? Okay, denominator, which causes asymptotes. What else creates problems sometimes besides denominators? Square roots. Why do square roots create problems? Okay, square root of -5 is a problem. Why is that a problem? It's undefined, right? I can't put a negative in a square root and I can put zeros as denominators. And just because you have it in pre-cal, one other thing you have to be aware of, you can't put 0 or negatives in the logarithms. So those are kind of your three big domain problems. Square roots, denominators, logarithms. Those are the three things that those come up, you know there's a domain. Otherwise your domain is negative infinity to infinity, right? You probably figured that out in pre-cal if you didn't know what it was again. You're doing it sometimes. Well, these are the three things that create not negative infinity to infinity domains. So I know that the denominator can't be 0 and the square root can't be negative. So I think this would cover all of my bases. X squared minus 4 has to be strictly greater than 0. How did y'all solve that out if you had an inequality? Y'all didn't do a sign chart? Let's check it out. Let's see. I'm not saying you can't do it the other way, but there's a lot of room for error. Okay, so pick a number less than -2. What's a number less than -2? -3. I would get a negative times a negative, which is a. And then something between -2 to 0. Positive times a negative is negative. And then something greater than 2. Positive times positive. Which ones of those work? Which ones are positive? Greater than 0. So So that would be the domain of that. So, pulling in some old stuff just for review purposes. It has nothing to do with what we're doing today, but I like to throw in some things you haven't seen in a while to remind you that you know how to do it. If there is another way you solve that inequality, as long as you're correct, just be careful that other ways do lead to lots of error in getting the wrong place in that. So, any questions about that? And a sign chart will come in quite handy. This is not. This is just. So today we're going to talk about continuity. Does anyone remember any definition of continuity from anything like maybe an algebra 1? It's not a very good definition, but it works. Definition. Or just if you can describe to me what continuity is. Something that continues. Try another. Anyone else can describe to me what it means to be continuous? What it means for a function to be continuous. Probably means it goes on forever. It does. But that's not the big part of it. Have y'all heard that word a lot in math class? Continuous function. Yeah, right? Isn't it kind of sad that we have no idea what it means? There's actually a really good reason that you don't know what it means. You have never been given a formal definition of continuity. Because the formal definition of continuity is calculus. So let's go back to Algebra 1 definition of continuity, and I know you all know this, you've just forgotten. You can draw a function without picking up your pencil. Y'all remember hearing that? You can draw a function without picking up your pencil, it's continuous. Right? That's obviously not at all mathematical, but it's something an Algebra 1 teacher had to say because they didn't have a definition. So, we can draw a function without picking up our pencil. How can we now define that? Maybe using limits. So if I wanted to say a function is continuous at any point, how could I define that using limits? First of all, let's maybe go ahead. Okay, good. So let's start. Let's say continuous at a point C. So f of x is continuous at C if and only if, that's the notation for if and only if, so the limit exists, is what you said. Absolutely right. The limit must exist for a function to be continuous at point. Is that enough? That question again, is that enough? Why not? There's a hole in there now, right? So I have to pick up my pencil at the hole, right? So the limit does have to exist, that's not enough. So there must be something else to it. What else do you find continuity. Continuity, its definition, has three parts, and I'm actually going to go to the next slide. This is the. Did we not just write that down? You told me that. So, this is the formal definition of continuity. You see why you didn't learn it now for one. You see why it's always been a little shady in your grade, because you have never been given a definition of continuity. You've just been told it's this thing that functions do, and you can draw them without picking up your pencil. Well, to make that definition formal, these are the three cases, or the three things that have to be true for a function to be continuous at a point. They did x equals a instead of c. So a function f of x is continuous at x equals a if and only if the limit is x approaches a of f of x exists. Do we all agree that would have to happen? The limit has to exist for us to have a continuous function. F of a has to exist for a continuous function. We gotta have a point defined. And the point has to equal the limit value. So this is the formal definition of continuity. Anytime on the AP exam that you are asked to justify or prove something, you will have to go back to the definition of what that thing is. And this is the first time that you're going to see a justify question. There aren't a whole lot of justify questions in limits. There are a lot in continuity. So this is the definition you will need to memorize. The good thing is you came up with it. So maybe if you forgot a piece of it, you could recreate it. So here's some AP questions from continuity. These are, first we're going to do some multiple choice. I'm going to read those to you, I know they're kind of small. The first one says the graph of a function f is shown above. If the limit as x approaches b of f of x exists, and f is not continuous at b, then what value is b at? So this is kind of going back to what is continuity. It's more of a limit question than a continuity question. So it says the limit as x approaches b exists, but the function is not continuous. What would that look like? The limit existing but not being continuous. There's a hole there, right? Everyone agree? So where is there a hole? Almost. At 0, at x equals 0, anytime you're setting where on a graph, they'll use x values. So the b value is 0. As x approaches 0, the limit exists, but the function's not. Everyone agree? If the limit as x approaches 3 of f of x is 7, which of the following must be true? You don't know what differentiable means, so you're just going to have to take my word on that part. So first of all, does it guarantee that f of x is continuous at 3? No? Agree? I have no idea. Does it guarantee that f of 3 is 7? No, because it could be a whole, right? So it's actually none. I know you don't know what differentiable means, and that's okay. So the answer is A, none. We'll figure out why that's not differentiable next chapter. Any questions about that one? Not necessarily. This is not a real AP problem, but I'll kind of show you what real AP problem does look like. It says use the definition of continuity to determine if the following functions are continuous to justify your answer. So again, this is not off a real AP exam, but there are real AP exam problems that look like this. This is the first time you've ever heard the word justify your answer. You will grow to hate that word, but it's okay. We're going to learn how to deal with it. Mathematical justification is not because the graphs says so. So we actually have to use correct mathematical wording, not perfect sentences and punctuation and spelling, not that kind of perfection. But the mathematics in your wording has to be correct. So before I do any justification, I just want to find out if f of x is in fact continuous or not. And I want to justify that answer. Okay. Well, to decide if it's continuous, and it doesn't tell me where at, so I'm assuming that means everywhere, right? We're going to see if this function is continuous everywhere. I'm going to graph it. You will probably never do this again on a question like this. You'll start to get to where you don't need a graph. I'm going to graph it. Since when x is less than 0, the function is x. How would you draw that? That way? Perfect. And what am I drawing that way? That would be that. So what about over here? X less than 0 is the line y equals x. What is the line y equals x? This, right? Except I'm only going to draw this side. Still work on piecewise and freak out some. No, maybe not. I may get some out or two. Hopefully get a little more freaked out. I'll do piecewise and freak out. Now right hand side, x squared, what does that look like? Parabola at 0, what is x squared? Still 0. What does that mean? It is continuous. Everyone agree it's continuous? That's not a justification, is it? Okay, that's, we know, but now we need to say that. F of x is continuous, so that's my first answer. On an AP problem, you would get a point for that, just making the conclusion. But then there would be more points for the justification. So don't forget to actually say the answer. Even if you miss the justification, you would get points just for the answer. You usually will. So then I have to talk about why. Well, the thing that I would say is y equals x is a continuous function, and x squared is a continuous function. Neither of them have domain problems, things like that. AP's okay with you saying that. Y equals x, and y equals x squared are both continuous functions. So where do I need to spend the bulk of my time in my justification? At what point could the problem occur? At 0, right? At x equals 0. It did say to use the definition of continuity in my proof, right? So what's my first thing I want to prove? The limit exists. And how am I going to prove that? When do limits exist? When the left and right limit are the same, right? So the limit, as x approaches 0 from the left of f of x, and I'm going to show my work. So this is the first time you've seen justification. Don't just assume they see what's in your head. I'm going to let them know I'm looking at that limit. What did I do there? I can do a whole lot. I said the left-hand piece is y equals x, right? I'm just telling the AP that I know that the left-hand piece is y equals x. So that limit is 0. The limit as x approaches 0 from the right of f of x Again, this is just me showing AP that I know what I'm doing. That means I'm going to come in on the x squared piece. As I approach 0 from the right on x squared, I get 0. Therefore, the limit as x approaches 0 of f of x exists. This particular proof is the most commonly missed probably on AP. I'm proving continuity or not. And you'll get into some way harder problems and you'll go back and go, why am I missing this continuity? There should always be 3 parts to your work on continuity. 1, prove that the limit exists. 2, what do I need to prove for the second piece? Third thing, that f of 0 exists. F of 0 is 0 squared. That's actually a quick part of proof to show you that. Why did I use 0 squared and not the x for that? Quick mental note. Good. The less than or equal to is on that bottom piece, so at 0, that's where I'm going to use that piece. The hardest part of this justification is number 1. And then number 3, that they equal. The limit as x approaches 0 of f of x equals f of 0, which equals 0. Now, I actually added this problem today. The justify, you can probably tell that the font was a little different. Most of the time I don't do this until the second day, but it's something that students are so bad about skipping over. I wanted to show you day 1 what justification looks like. If this did not say justify, you don't need any of this work. This is only if it says justify. You have to show why it's true. Any questions of that? On the next one, I'm not going to justify. I just want to say, is it continuous or not, and why. From our knowledge, it is different from an AP justification. AP justification looks like this. We're going to go through and show for AP purposes that that function is continuous. That's what we need to say. Okay. On the right, I just want to know, is it continuous or not, and how do you know? I'm going to go a little faster through this one and show you that you won't always have to graph. I will graph it after I decide if it's continuous or not. I'll show you that it is. Would you agree that x minus 3 squared is a continuous function? It's a parabola moved right through. Would you agree that 2x minus 1 is a continuous function? So, if I want to know if this is continuous or not, where am I going to look? At 3. Why at 3? That's where I'm switching from one function to another, and I want to know, did I switch to the same thing? Even though I'm not going to do this full justification, this is what I'm going to go through in my brain. The first thing I'm going to look at is the limit from the left and the right. Okay. What's the limit from the left? You get 5. Put 3 into 2x minus 1. What's happening is 2x minus 1 approaches 3. As 2x minus 1 approaches 3, I would get 5. Open circle. So even if I didn't know what this looked like, now I do, right? Looks like that. X minus 3 squared. What's the value as x approaches 3 from the right? 0. Is this function continuous? No, I don't have to know anything else. In fact, even on a proof, this is an easy question. F of x is, so I said I wasn't going to test what I like. Not continuous does not exist. So this function is not continuous at 3. So finish the graph. This looks like this. Parabola would write 3 in a line. Any questions about that one?
Is that all we have to do to justify?
That's all you have to do to justify, because if one of the 3 pieces doesn't work, then the whole definition is shot.
So would you have to
No. Only if they told you to graph it, but most of the time they won't.
So since number 2 is easier to justify, can we just put that check that compare to 0 equals 5?
Yes, with this notation. That probably would be about 5. So it doesn't exist. And that's enough to say that number 1 fails. If number 2 failed, if number 3 failed. One more, and again, I'm not going to go through the full justification. I just want to know, is it continuous or not? There will be a justified continuity question on your test. So know that that's coming. You will have to do that on your test on Tuesday. What are my thoughts on this one when I first look at it? Okay, 15x equals 3. That means f of 3 is 15, right? Okay, so f of 3 exists. So I got number 2 because of that middle piece. What's the limit from the left? Or what's the limit from the right? So number 1 works, and number 2 works, but no, does number 3 work? Now we're walking through this again. This is not justification. Just say 3 to be done. Number 1, the limit as x approaches 3 from the left. And I'm showing so much work on this one. The limit as x approaches 3 from the right. Will equal 5. So the limit does exist. And it equals 5. So far, so good. But f of 3 is 15. Which means number 3, limit as x approaches 3 of f of x, does not equal f of 3. So again, we'll look at that on the picture. We have x squared minus 4, and that's to the right of 3. And then to the left, I get 2x minus 1. That almost looks like the same function that it is. The left is a line, right is a parabola. It's just that straight up piece of the parabola. And then at 2, I have 15. So it's like I've got a dot there somewhere. Or at 3. So it is not continuous. Because case 3. The limit is x versus 3 does not equal f of 3. Another type of question that they'll ask you with continuity. I remember to bring a battery for my car today. take this and take it a step farther when we learn derivatives, and they'll say continuous and differentiable and make it even a little bit more fun. Very common AP problem. We know ax minus 5 is a continuous function, it's just a line. We know x plus a is continuous, it's just a line. So if this didn't work, where would be the problem? At 3. Why at 3? That's where they meet. So normally we're wondering, do they meet in the same place? Now it's make them meet in the same place. So if I do the limit from the left and the limit from the right, how do you normally do that? Plug in 3 into the top and plug in 3 into the bottom. And Jameen said then set them equal. Makes sense? Because we need the limit from the left and the limit from the right to be the same. So I'm going to do 8 times 3 minus 5. And I'm going to set that equal to 3 plus 8. We're going to see how I did that. So the left-hand side has to equal the right-hand side as x minus 3. So just rewrite 3a minus 5 equals a. Solve that equation for a. And see if it worked. 4a minus 5 and x plus 4. If I plug in 3 into both of those, do I get the same value for the line? It's a lot quicker to mentally tell if it's continuous than to prove if it's continuous. So we love these as multiple choice questions. We don't particularly like them as quick response questions. A lot of stuff. Sometimes they'll even just ask questions about what values is continuous or not continuous or just multiple choice. The bulk of your AP thing will be multiple choice. You know, there's only 6 of the response questions. But when they do put a continuity in there, those are easy questions, even though it takes us a while to write them. They're easy, so we want to know continuity. Every now and again, I'll throw in continuity response. You never know what occasionally come up. It's when a teacher's cringe at me, because it's an easier concept. It's generally just been so long since you've looked at continuity, but I will remind you. We'll do it. We'll do it. Which of the following functions are continuous at x equals 1? Your pre-cal graphing knowledge is probably the best thing you can have. Being able to look at these graphically. If not, we'll try plugging them in, looking from the left to the right. Do you have a sketch of natural log of x and e to the x in your brains from the pre-cal? If you don't, you might want to get those back. It will be quite helpful. E to the x looks like this. Natural log is the inverse of that, so x and y is switched. So natural log looks like this. We'll put them in here now. Why would a graph be helpful? We have to think a whole lot less, wouldn't it? Are those continuous at 1? Are they one? Both of them are. Now, log isn't at 0, but at 1 it's not. Here. It is. Looks good. Is e to the x continuous at 1? Yes, looks good. So now the question is the one I can't graph in my head. I don't know what natural log of e to the x minus 1 looks like. I'm going to look at what would happen if I plug in 1 into E. What's E to the first power? E. And E minus 1, well, E is about 2.7. So E minus 1 is something bigger than 1. Is natural log okay at something bigger than 1? Only time natural log is not okay is at 0, right? Or before. So actually 1, 2, and 3 are all continuous at x equals 1. This would have been a non-calculator question, so that's what makes it tough. Any questions?